Welcome to the UpStreamLife.com, a podcast that celebrates business transformation. I'm your host and founder, Vishal Krishna. Today, I have with me Jim Keller, a renowned microprocessor engineer who started his career 42 years ago. He has worked with the likes of Intel, Tesla, AMD, Apple, and Broadcom, and the list goes on. He's currently the CTO and president at Tenstorrent. For those of you who don't know what the company does, let me tell you about them. Tenstorrent is a pure-play, fabless AI chip design and software company. They create and design silicon for machine learning. Then they use a foundry to make the hardware. They work with partners to create solutions as a package. It could be chips, systems, software, optimizations for any customer. Jim, it's amazing to have you on this podcast. Thank you so much.
Yeah, sure.
So Jim, can you tell us a little bit about your history, right? You started off at Aris Corporation, right? And you stayed there for a good 16 years. And then, and you've been through multiple companies, you've seen multiple technologies. How did that transition happen for you?
First, I went to Harris because I wanted to live near the beach and surf after college. So that was down in Florida, and I was there for about a year and a half. And it turned out to be a great job because I spent a lot of time fixing things. I worked as basically an engineering tech in a lab, and I learned to use all the test equipment. And I fixed a whole bunch of processor boards, and they had power controllers, and there was a fiber optics group, and they had a fiber optics interface board. So it was one of those jobs. When I did it, it seemed like one random dumb thing after the other, but it was really good. And then somebody told me I should work at digital equipment. So there was a newspaper, EE Times or something, and I found an advertisement for a job opening at digital. And then I read the VAX 11780 manual on the airplane while I flew up to the interview. And I had never studied computers. I was an electrical engineer and probably more of a E&M fields and circuit board designer than a computer guy. Like, I'd taken one programming course, but they gave me the job for some reason. I was there for 14 years, and that's where I learned computer design. And I lucked into a really great group, which had some really great designers and architects. I worked for a guy named Bob Stewart for years, who was one of digital's, premier processor architects and system architects. So partly luck and partly, direction, let's say.
Okay, in your career, right? It makes sense. Yeah, it makes sense. What drove you, right? One of the things that I've been studying, I've been reading about you is, you worked in the cutting edge of microchips and the way they're utilized. Is that the common theme that drove you from 1980s onwards all the way up till 1998 plus? Is that what always drove you?
I like doing things, right? And I like figuring things out, and I like making things work, right? So when I was working on computer designs, it was like, okay, they design computers. I really want to figure out how that works. And then, to build computers, you have to understand microarchitecture and some modeling and circuit design and schematic capture and some CAD tools. And I just sort of worked hard at a whole bunch of those things. And as I did it, I learned a lot. And then also, it turns out almost everything about it is in some stage of development. Like, our understanding of how computers were built in the 1980s was a lot better than the 70s, but it still wasn't very good. And there was so much to do. And the same with the CAD tools. Like, we used a timing verifier that was expensive and slow and difficult to use and gave unreliable results. And at some point, I wrote a new timing verifier, which verifies the path lengths between flip-flops in a computer, which sets the frequency. And, me and another guy wrote it, and it was 10 times faster, way simpler to use, way better. I learned a lot doing it. And that was fun. And, lots of people used the tool and really liked it. So I did, hands-on programming for a simulator, a timing verifier, some other tools, and continued to learn, computer architecture mostly by doing.
So you were doing these validating these path delays back in the 80s itself?
Yeah.
Wow. And all on your free time or for the corporations that you work?
Oh, no, it's work. I used to work a lot. Like, when I was a kid, when you graduate school for the first couple of years, you better like what you're doing enough to work 60 or more hours a week. Like I used to be frustrated that Saturday would show up, but then I realized Saturday and Sunday were great because there's nobody around to bother me. So I could just work Saturday and Sunday. But then later on, I found out that the reason there's a weekend is you need to give your mind a rest and put things down so your brain can actually work on them unconsciously. So it took me a while to, change to, work really hard during the week and then go do something random or fun for the weekend or nothing. Because your priorities on Monday are never the same as Friday if you take some time off. But yeah, I work for digital. I work very hard for, I think, 14, 15 years.
A lot of this generation takes for granted the computational capabilities. Like you said, the 80s were better than the 70s, the 90s were better than the 80s, and so on and so forth, right? And this ongoing shift towards ML-centric software, where computational capabilities are going to become better and better. And you say that, the understanding of physics would be better through an AI than humans doing it. Is that true? Is it really true that computational capabilities are going to get better every 10 years or even better, even faster than that maybe?
Well, people have been using computers to do stuff since like the 50s. Like they had, non-programmable stuff in the 40s, but starting in the 50s, people wrote programs, and the 60s and 70s was amazing. They invented most of what we think as modern operating system principles on very slow computers. And then the 70s was elaboration, and then the 80s and 90s, we made huge advances in computer microarchitecture. So I don't personally see a reason why it's going to slow down much. But here's a funny thing. So as a designer, I've always used computers, right? And the computers were always a little too slow, right? And what's happened is that slowness hasn't changed much, right? Because we now design computer with way more transistors in them. And the computers we use to do it are way faster. And we're sort of at a balancing point because humans can't deal with things that take longer than a couple of weeks to do. And things that take less than a second to do are too easy to be valuable. So we're kind of, adjusted to this window of like how long it takes to do things and how hard it is. And it's you can do the math, like the computation times the number of transistors is a constant or something like that. And
that's good. So neural networks have a better understanding of physics. I think that's true. And a lot of students keep asking me this, right? They want me to ask you this specifically. They want you to tell them how are you evolving utilization of chips beyond scalar math and pushing towards vectors with graph computation.
Okay, so I'm working on a talk. So there's two kinds of computers now. So we used to think there was CPUs and GPUs and accelerators. But pretty soon there's going to be two kinds of computers. There's AI computers and deterministic computers. And deterministic computers are things that run programs like a C program or a Java program or a web browser. And an AI computer is something where you train a neural network with data to do something, right? And then those two kinds of computers will work together. Just like your brain, like you have a cerebral cortex where you mostly think, you have some other structures that help with memory, you have a motor cortex that moves your body. So you have specialized pieces in your brain, and computers are going to be the same way. We're going to have deterministic computers like we call CPUs or GPUs that run programs that humans write, well, for a while anyway. And then we'll have AI computers, which are trained by data. And then we'll have networks that move data around and storage. So, and they'll work together. Like you'll have an AI program that's data driven to say, find a path or control something, but then it'll want to have a program run to do something for it. The same way, like you think, oh, I want to walk across the room and make a cup of coffee. but then you give instructions to your motor cortex that makes you stand up and, does stuff that's, let's say, relatively specific. And the dividing line between an AI computer and a deterministic computer is sharp, right? They're going to do very different things, but they're going to collaborate together, right?
Okay, that
And then
makes a lot
you're
of
asking,
sense,
there's a different question, which is, can AI computers understand physics better than other things? So let's just, here's a little history lesson. We used to think scientists would observe a phenomena and collect data, right? So you'd notice how fast a rock falls to the earth, or
the
how
acceleration,
how light goes through air to water, right? So they collect a bunch of information, and then they come up with a theory, and then they often write down some equation that say, E equal mc squared, or the index of refraction is such and such based on the angle of light, and so there's equations. Now with neural networks, you can take a large amount of data and then construct a model which predicts what the system is going to do without actually having the equation, right? So it used to be, data led to some theory, which led to some equation that maybe a scientist or an engineer could use. And with neural networks, there's many phenomena where we create neural networks which basically do things, but you don't have a defined equation like that. And some of those phenomena are very complicated and subtle, and it's not obvious that you could have a set of equations.
Yeah,
but neural networks and neuroscientists, AI researchers can find it. So
you're right. And the brain, I sometimes wonder, the brain has so many million levels of output, right? That the calculations, when you talk about, so would I be correct in saying that I'm a fan of Isaac Asimov, and in his books he says robots can dream. So when in a computing world where the transistors are better and faster, do you think that's going to happen? In a sense, I'm just throwing it out there. What is really happening now? The computation speeds are really growing.
So scientists hardly have any idea why we dream or what's going on.
Yeah.
Right.
Yeah.
So a theory, I've read this theory, I don't know if it's exactly true. So when you go through your life during the day, you're inputting things, you're doing things, occasionally you're thinking about things you don't know. When you dream, your brain is literally reorganizing that information. It's replaying it in complicated ways. It's readjusting it. I've often felt that almost all my good ideas happen when I'm dreaming. When I work, I like to work to do things and to learn things, but you need to sleep well and you need to dream because your brain reorganizes it. So imagine you have an AI system that's learning lots of things and doing lots of things, and then periodically it goes into dream mode, where it replays what it knows and creates new scenarios, and then adjusts how it stores that information. So there's no reason to think that AIs won't dream. Now, humans, when we dream, sometimes the dreams are really fascinating and unexpected, right? And things happen, and nobody has a good theory for that, to be honest. And it doesn't seem, it's too simple to say your brain is replaying the information. But in fact, when you learn stuff, if you get good sleep as you're learning it and you have some time, you'll learn it better than if you cram it in your head at the last minute. I had friends that used to study for the last 2 days, get an A on the test and forget it. And I don't work that way at all. I would always do the work ahead of time, and the last 2 days not study, because anything I learned at the last minute would just confuse my simple thinking. And then I always remembered everything I learned. So I use sleep to think, but there's no reason not to think that AIs won't have something that's like simple dreams, but whether it'll have anything as complicated as what we do, who knows?
Okay. That's so true. Okay, I have a business question for you.
Sure.
Everyone says machine learning can predict things faster. There's function output, obviously it's faster. But what is progress in computer architecture, right? That's always fascinated me. I always thought if you want to increase computational capabilities, there has to be something new out all the time, something new and better. But I'm sure that the business people who are, probably in the automotive world where I cover automotive, that they'd say, why do you need a new chip? Let's stick to this category for say 7, 8 years, right? For example, I'm bringing it from the business perspective, right? And it's shareholders return. Why do we have to invest in this new architecture and all that happens now? Right? What are your thoughts on that?
So there's a whole bunch of driving factors, right? So one is, generally speaking, the semiconductor industry generates more transistors that run faster, lower power every couple of years. And that's pretty steady. And there's reports that Moore's law is dead. And then meanwhile, TSMC, Moore's law is not dead. They're doing fine. It slows up and speeds, slows down and speeds up a little bit. It is useful to pick a technology and run with it, because when you first adopt a new technology, it's expensive. And then if you use it for 5 years, you make it cheaper, you get good at it. But meanwhile, the base technologies improve so much, you'll be out of date. And game consoles are like that. They put out a new one every 5 years as a very stable programming platform. And then you can see the games get way better over 5 years, even though it's the same hardware. But also inside, they're making it lower cost. And then they come up with a new one, which is a big step forward. So yeah, it's interesting. So for a product, a time frame of like 5 to 7 years can make a lot of sense. But for technology developers, we kind of chip away at it. Like, we don't take a big step every 5 years. We take a small step every year. And sometimes you go, well, we made it 10% better. Well, 10%, like, could you care? Could you tell? Like, if your computer was 10% faster, you wouldn't notice, right? No. But 10% for 10 years, it could be night and day. It could be twice as fast. It could be half the size, twice the battery life. Like, those numbers you notice, right? So technology is about compound growth. And the business guys have to go, I'm going to invest in this new platform. Like, for automotive especially. I worked at Tesla, which is super fun.
Yeah.
But there's so much technology in cars that's so out of date. Like, cars could be cheaper, lighter, better. Like, there's a whole bunch of things to do. And their problem is they're so used to building the old kind of car, and then it's so many pieces go together. It's very hard to make a big change with 100 components. Like, because you have to literally change most of them at once. And that slowed down the rate of change, but somebody's going to do it, and then everybody's going to scramble. So
that's true. But so rewrite is the only order of the day then?
What's that?
Rewrite the architecture. The architecture changes all the time. It has to change dynamically.
Like, some things change incrementally, and sometimes things change in a big way. Like when they first started making cell phones, you remember, they were big bricks, and they incrementally got smaller, right? And people were pretty happy with them, yes, right? The screen got a little bigger, the buttons got a little better. And then the iPhone came out, and it was like, what were we thinking? Like, you see a movie, where somebody's holding up a satellite phone to their head that looks like a shoebox. It's ridiculous.
I remember.
Like, everybody's got one of these.
Yes.
That's it. Like, now this has been incrementally getting better, but I promise you, there's a new device going to come, and you'll see a movie with somebody holding an iPhone, and you'll think, well, that's ridiculous. Like there's not a chance that technology is going to be great in 10 years.
What is the software 2.0 strategy in Tenstorrent? A little curious. I know the current generation product called Grayskull, and there's a future in line called the Wormhole.
Yeah.
There was something called the Jaw Bridge in the past. Mm-hmm. What does this mean for the end customer?
Yeah, let's talk about software 2.0. So
yeah.
Software 1.0 was, you write programs, like human beings write programs. And then I think Andre Karpathy coined software 2.0 is where you collect data to program a network. And I believe we're going to go to 3.0 pretty soon, but we're still working on what that is. So our processors, AI processors, make AI programs run fast. And the reason for that is if you look at how the program is written, it's large amount of computations organized as a graph, and data flows through the graph. And we built something basically called a data flow computer, where you take the graph and you lay it out across a number of processing elements and data flows through naturally. And there's a bunch of reasons why it's several times more efficient than running it on a CPU or GPU. And then the software stack we're building, it sort of starts, it meets the programmers. So programmers write in PyTorch or TensorFlow. They express their what they call models, right? The programs are kind of the description of how to process the data. And then we compile that into a graph. And then there's some interesting steps about how you lay the graph out on arrays of processors. So that's our part of the software technology, is transforming the AI researchers' program to a graph to lay it out on processors. And yeah, so what was the other part of your question? Like, what would that mean to customers?
Yeah.
Well,
yeah, the customer, what does it mean for the customer? Yeah.
So there's two things. One is, like, partly because of our price and partly because of the efficiency, it's going to be several times better than the competition for your ability to do it. And then the other is, when you write new models, you'll get the peak performance of the machine easier. Like when you run something on a GPU, if you have a model that many people have optimized, you can get good performance. But if you do a new kind of model, the performance won't be very good. So it takes a large number of people writing low-level libraries and doing lots of optimization work to get good results. And what we're trying to do is let people write, like PyTorch programs the way they want to, and have that translate to good results pretty easily. Now, it turns out that's pretty challenging. This is a hard, computer science problem. And we've written our compiler several times. And each time we do it, we've learned a lot. And we now have a new version that we like a lot better. That's going to be pretty straightforward for people to write the code and then get good results.
Okay, Jim, you're coming down to India. I think Tenstorrent is going to set up office in India as well. Your thoughts on India as a market? You must have traveled here. Have you traveled here in the past? And what do you think about India building for the globe? Because I go to a lot of engineering colleges, right? And everyone's now thinking product, but because of the network of VCs or venture capitalists, there's a lot more focus on the business to consumer market. I think it's in mathematics, it's in physics, where the real love for the future begins, right? And Tenstorrent can offer them all those things. I want you to talk about the talent in India. What are you looking for? And how has India itself changed? You must have seen it grow over the last 2-3 decades.
Well, sure. Like when I first started working with engineers in India, the experience level was lower in the United States, simply because they hadn't been doing high-tech engineering for as long. And there was also, in the early stages, graduates from IITs had to go to the US to get a job, right? And then they started realizing there was all this good talent in India, and they started setting up engineering offices, but they were typically support engineering. So, but then in the last 10 years, there was a huge return of experienced people, but also locally, people got a lot more experience and stopped being, let's say, support teams and really being teams that own things, right? And that's been a big change since I've been working there. I worked at AMD, I worked at Intel, that both had very large engineering teams in India. And I had a lot of fun working with them. I would say, the enthusiasm level with the engineers is high. And then the key was always, getting the group organized properly and getting the right kind of work for them to do. and collaborating on the stuff you have to collaborate on properly. Like 12-hour difference is a pretty big difference for a US based India team, but we figured it out, and I had really good success there. So on the business side, so Tenstorrent's opening up an engineering office in India, not a sales office, not a, like, we'll see what happens long term in terms of customer support and all that. Some of my team is very enthusiastic about working with engineers there. We reached out to some people and immediately had a whole bunch of people say, yeah, that'd be great to join Tenstorrent. So we're opening up an office there. We've incorporated, there's a bunch of legal paperwork that's done. We have our first, probably 10 accepts, and people are starting. And then I'm going to go there and meet a bunch of people and talk to the people we've already hired in person. I've talked to most of them on Zoom, and then we'll see what's going to happen next.
Okay.
We have a couple of exciting projects that I'm really keen on. We're building a RISC-V CPU, and we want to do it in a novel way, which is architected really carefully from top to bottom to be very verifiable, very modular, use basically modern software techniques for all that. And we're doing the design from scratch. And this is really important for young engineers. Sometimes it's good to go work for an experienced place where you do your little piece with incremental things. But man, you have to work on something where you have a clean piece of paper in front of you and do some original design where you did everything yourself. And so the thing we're going to offer is that opportunity in a, let's say,
great opportunity.
In a modern context, we have very experienced leadership team, but we're looking for engineers who really want to, stretch their wings and, write some new original design, and at every level. So it's going to be a really good group. So I'm really happy.
I'm glad you brought that up, because you would write papers on chips in the early days, right? You still continue to. Would you encourage young people to think that way, to write papers for universities, also do some research on the side? Is that a good thing to do?
I've written very few papers. Maybe
okay, but do you think it's a good thing to do?
So I'm dyslexic, so I don't write. I'm very good at talking or writing on a whiteboard or programming. Like I like to do those kinds of things. The problem with papers is you're looking for novelty in some field, where when you build a product, you're looking to build a winning product, right? It's a very different thing. It's like the difference between, like, if you're a runner, do you run to win the race, or do you run to be a different kind of runner? Right.
You run to be a different kind of runner, right?
Yeah, if you just watched 100 people run and they weren't competing, how could you tell which one was the best runner? You'd probably admire the person with the best form, or the best shoulders or something. Who knows, right? But when there's a race, you know who won, right? So in product world, you focus on building a winning product. Now it may be speed or quality or cost or the time it took you to do it. There's all these things. So I'm a product person. I'm not a research person. Now, to build a winning product, sometimes you incorporate new research ideas, and sometimes you come up with them yourself. And then there's a funny thing, which is in computer science at universities, they research lots of stuff. Some is very good and novel. Some of what they do is actually the same as what big companies have already done, because they keep it a secret. So, yeah, I encourage people to find a place where people are going fast, they think clearly, they have good product direction, they have an opportunity to learn, but they also have the opportunity to work on something that's going to be a great product. Right.
That's really great. And how was it for you? I mean, to move from a large corporation to a startup? I mean, was that a conscious decision?
Oh, there are different kinds of problems. Yeah, I like those kinds of problems. I love working at it.
Tell us about it. I'd love to hear about it.
Yeah, I loved working at Intel. There's really great people there. My team was like 10,000 people, which seems ridiculous sometimes.
10,000 people, my God.
It's a pretty big village. It's a medium-sized city.
Yes.
So the challenge there is to, how do we organize that properly? Like, how do we make sure the different groups have clear clear paths on the products to build. And then there's lots of tools and infrastructure. Like with 10,000 people, you spend a lot of time building roads and, plumbing, and, there's all kinds of details like that. Where startups more like Labija uses the line like a bullet. You have to aim at the thing that's most important to do. So the startup, everybody is working on getting the chip done or the software stack done or defining a new processor. It's much narrower. You take advantage of the industry for stuff like CAD tools and libraries and technology, open source software. So startups have a mindset of make the concentrated advance, where a big company is, how do we move the whole village forward in a useful way? And they're both really interesting problems. I like them both.
No. That's a good problem to have, right? I mean, and the fact that it keeps your mind fresh, and I want to get into mental health and how do you manage, managing teams across different geographies. Is it an easy thing to do, especially with the world getting younger? I mean, in India, the average age must be 27, and even there in the US, maybe a lot of young folks out there.
Yeah, I don't worry about that very much. So I like to work, and I like to meet people. So whenever you work with people, so there's good people who want to get something useful done, and then there's people who are, let's say, troubled, right? They may be confused. They think they want to get promoted, or they're for some reason they've become political, and then there's a small number of people who aren't doing very well, let's say. So I like to work with people who are smart and active, and they're like, yeah, I want to make this better. I came up with this idea. And then the troubled people, sometimes there's a problem to fix. Like they're confused about their career, or they think the way to get promoted is to look right instead of getting something done. And so I've worked with lots of people about that. And then in organizations, there's always some people who actually are not helping. And sometimes you can fix them, and sometimes you have to let them go. But that's all interesting. Human beings are very complicated, and everybody shows up with all kinds of stuff. They got their history, their family, their capabilities, their insecurities, their education, some bad experience, family trouble.
Do you remember Frank Zappa? You know what he said?
Oh, what did he say?
You know what he said? He said before he died in 93, he had a synclavier and a synthesizer. He said, I'd rather work with a synthesizer because it doesn't make mistakes.
My
Humans
father
make mistakes.
No, my father said something like Frank Zappa then. He said, there's two kinds of problems in the world. There's technical problems and people problems. And technical problems you solve, and people problems go on forever.
Ever and ever.
So the challenge when you're designing stuff is you have to take that seriously.
Yes.
Right? You have to meet people where they're at, but you also have to be very clear that we are going to solve these technical problems. And while your life's journey and working on your personal problems is something that's important, you can't let it dominate your life or what we're doing. So you have to move them both along. Like, I know engineers are like, I don't want to deal with people. They're just, well, then how do you scale a team? How do you put 100 people together? How do you work together? On the flip side, if all you ever do is work on everybody's personal problems, which, as you know, could go on forever, you'll never get anything done.
Yeah.
So you have to balance that out. So Frank Zappa said, I only want to work with the stuff I can really control.
Yes,
that's
absolutely.
not scalable. Like, you can't build a large technical company with one person. Well, there's a few.
Absolutely. I completely agree with you. And therefore, Frank Zappa was about his music. You're right. And that is so true. And there are a couple more questions.
He also had, dozens, maybe hundreds of great musicians who loved his vision that would sit down with him and do it, but then they would go do something else.
Yeah, like Steve Vai and people like that. Yeah. Absolutely. A couple of my students have asked me a couple of questions, and I definitely want to bring it here. They say, what is the future of the microchip? Is it fundamentally moving away from silicon wafer chips?
No, we're going to do silicon for a while. So there's a great picture. You can go look out on the web if you search for it. like which atoms in the periodic table are used in semiconductor manufacturing. And every year or two, they add a couple of atoms. It's really amazing. But the substrate has been silicon for,
years now.
years. And silicon is very useful for a whole bunch of reasons. And there appears to be, like EUV is what, 13.5 nanometer light. And so that's the right way to say this. There's all these optical tricks to write stuff about 10 times smaller than the wavelength of light. They're with the old optical lithography was 130 nanometers, and they got down to writing 7 nanometer transistors, which is kind of amazing. Then they switched to EUV. Now there's gonna be a new set of tricks. So I don't know. There's probably a factor of 100 density on the current silicon stuff. And then there's other techniques that are, let's say, way better than that. So we're going to have silicon with us for next 10 years.
Okay. There's a question on photonics and quantum computing. Pardon me. So my friend says photonics and quantum computing form a big hype across the world. With all the major countries in possession of quantum computers, do you see a future where quantum computers will be bought and sold openly in markets, just as we buy an AMD Zen or Intel chips today?
So
it's a student. He works on he works on chipsets.
So photonics is deterministic processing using light instead of electromagnetic waves. It's making a lot of progress. So we've thought we're going to use photonics in servers in 5 years for the last 15 years. We're getting close. There's something called co-packaged optics. There's a whole bunch of reasons why we'll start to see optics hooking up silicon chips more directly in the next, I'd say, 5 years. But it's been 5 years away for so long that, we'll see. We keep solving the problem. Like when you go from 100 gigabit to 400 to 800 gigabit, the power goes up so much, people think, well, optics solves this. But the engineers are really clever because optics is fundamentally more expensive. And if you can solve it with normal, electromagnetic signaling, it's so much cheaper. So we'll see what happens. Now, quantum computing, I know a researcher who worked on it for 10 years, and when he was done, he wasn't convinced that it was real, right? So everybody's talking about quantum computing, but I don't know if you've ever seen a quantum computing device. They're quite large. You need lasers. You need all kinds of equipment to keep things cold, to do stuff. There's no path currently to putting a quantum computer in your phone. Like, it's not a thing. And then the number of things it can do is somewhat limited. It's sort of unlimited computing on some narrow problems that aren't that generally useful at the moment, I would say. And I'm not an expert at it. The physics of, qubit coupling and getting atoms to be held in a spot at 0 degrees Kelvin is super cool and fun. But, as a computer scientist, it's a very limited set of things to do. And to date, it's been in the news for longer, it's gotten more media than use, let's say.
Okay. Question on, some of these end use of the applications, pardon me, blockchain. They say, and 7 years ago, even the word AI didn't show up in Google search, but now shows up all over the place. I know AI is mainstream, machine learning is mainstream, but every startup uses it, and sometimes you can't believe what is real and what is not. So I want you to tell me, in reality, where is AI today, and where is blockchain today? And I don't want even to get into the world of crypto, because that's a different topic altogether. So AI versus blockchain, are they going to converge, or are they going to be decentralized, centralized, two different things?
To be honest, I don't know anything about blockchain. As best I can tell, it's a distributed information technique using cryptography and other things to validate a whole bunch of premises. But to me, that's software computer science. I don't know.
Absolutely.
AI is really interesting because we're on the third AI hype cycle. And a friend of mine pointed out, this is really interesting. The things you can do with language models are unbelievably interesting, like GPT-3, but those models are very expensive to build and train. Like, it's not obvious you can use that, for 1 billion people every day. Like, the cost is really high. So, and AI looks like that a whole bunch of places. So you get these really good results for certain things. It's very difficult. It's not in the state where you can sit down and plan it for the large part. There's 10 autonomous driving startups all using AI to drive a car, and they've literally all been going sideways. They're making progress, but they've been going sideways for like 5 years, right? And I think it's going to solve, and we're learning a lot doing it, but it's still very much in the new science phase. Like, people are learning a lot, they're doing a lot of things. Some things they think are going to be easy turn out to be really hard.
Yeah.
It's very different than if you say, I'm going to write a new application with a website and an app in a server backend. You can say it's going to take 20 people, 6 months, and here's the project phases, and you'll get a result. But if you do the same thing with AI today, you don't know if it's going to be 6 months or 3 years. You don't know if it's going to finish. You don't know if the team is going to be able to do it. We're very much in the early stages. But that said, I'm very convinced, 80% of the world's computing is going to be AI in less than 10 years. And so it's moving fast, but it's very uneven and new.
And so because of AI, would the race to making the best, faster chips continue? I mean, would that be the race that everybody wants to be part of? I used to attend Amazon's conclaves, and they were investing in a chip at the time before COVID hit. I don't know what they've done with it. So everybody's getting into this race. Do you think it's going to play out with a winner take it all market, or it's going to be based on devices? Is it going to be data centers? Is it going to be end computing devices? What's going to happen in that race?
Well, at one point there was 30 odd graphics startups.
Yeah.
Right. And it reduced to probably 4 or 5, and some big companies have their own graphics and there's ARM, Intel, AMD, NVIDIA, Qualcomm has the device, a few other people do. There was probably 50 network processor startups, and there probably still are 5 to 10 people who do network processing specific hardware. There's always a place where new science people will explore the space, and then it consolidates. It's probably not a winner take all. Like, the applications are fairly diverse, and then some big companies are holding, like Google builds TPUs. It's one of the best AI platforms on the planet, but they don't sell it, right? They keep that. And I think there's some fundamental unsolved problems on how AI software is written and how it runs. And so this market is fairly open because the final answers aren't obvious yet. And that's why, like, I joined Tenstorrent because, like, AI is the future. The platform I really like. I like the idea and approach. I've worked with these guys for a while. It was the best way for me to, hands-on, go work on AI rather than starting yet another new AI computer like that. We don't need another new AI startup today exactly, but of the 50 or whatever number there needs to be a lot of development to make it successful. And success is a programmer says, I want to do this thing, and they can sit down and write their code and do it and get a good result for a reasonable cost and make all the right trade-offs. Like, that's a difficult problem. And today there's lots of issues with that. But as we do that, then AI will be applied to way more things. And that's the...
Absolutely. Yeah. Would you encourage young people to rewrite more, work on the architecture? Because today everything's open source, right? So go rewrite, experiment, try several things, or would you just say, come to Tenstorrent, learn how to build things and go on and do better things?
Well, when you're in college, you should do basics: math, physics, chemistry. Programming is basic. Learn to read and write. Read a lot of books. You got to build up your fundamental knowledge and capability. Like, if you want to play basketball, you play basketball, but you also lift weights, right? And you eat right.
Yes.
You have to have your basics. When you get a job, you should work for somebody who really knows what they're doing, where you feel like every day you're learning a lot and you like the people you work with and you feel productive. And on a regular basis, you learn something new. Like if you go to work and you feel like nobody knows anything and we're not getting anything done, and I feel sad about the direction of the company, go find another job, because there's plenty of jobs. Right now, engineers are in demand. And if you're an energetic person getting stuff done, you should be at a place like that. And then you should read and you should think about things.
What are you reading, Jim? I'd love to know. What are you reading? What are you listening to?
Oh, people always ask me that. It's like, tell me the 3 books I should read.
No, what are you reading?
I read
I just want to
1,000
know.
books.
Yeah.
Like,
you can't pick one.
I read stuff all the time. I like to read, bloggers, and I watch YouTube videos of guys like you, and I think about what they said. And, I just watched some Lex Friedman interviews with Josh.
Yes,
Shabaka.
I love that. I love it.
Yeah.
It's amazing. Lex Friedman's amazing.
Yeah, so I watched 2 with Josh Shabaka, and they were great. Mm-hmm. And half of what he said I thought was brilliant, and half of what he said I thought was maddening and wrong. And it was very stimulating. So then I had to go read a couple papers he mentioned, and it was very curious. I really like finding thinkers like that. My favorite book recently was a book called Against Method.
Against Method, okay.
Feyerabend, which is basically a theory of science that's very different from what's classically taught as science. And I really wish I'd read that book 20 years ago, because when I read it, I thought, oh crap, I've been thinking about this so wrong. But I'm 63 years old and I still wake up and think, oh crap, I'm completely wrong about everything. And
do you ever get time to understand the human condition?
The human condition? Sure. I work with people all the time. People walk up to you and they do all this human stuff right in front of you. You can't help it. You work with people, I know something about the human condition.
So my question, do you read about history?
A tragedy and a bit of a farce.
Yeah, true. That's true. That is true. Do you read history at all? Because you encompass, I've seen so many of your lectures, I've seen so many of your podcasts. You bring in the science, the history of science into things. Is there something that you get inspired by?
I occasionally, I was reading a book, a friend of mine recommended a book about England during the American Civil War or American Revolutionary War. It's fascinating. I've read a lot of history, over the years, but I'm not a history buff, but sure,
But it was during the American Revolutionary War that they began to conquer much of the Indian continent.
Oh, I know. But the way people thought back in 16, 17, 1800 is it's such an alien mindset.
It's funny how they moved from America to in India in no time, because they lost America and they moved to India quickly, and they did not make the same mistakes. They did not arm the local militia. Instead, they focused on building an army.
Oh, that's interesting. Yeah, I don't know. Yeah, well, the most unlikely thing in the world is that England conquered India, but it was, as I understand it, it was a very complicated thing, because India, politically, it was a very complicated region.
Yeah, absolutely.
And there
were 8 different currencies.
Yes, yeah, and probably 100 different states, and
yes,
yeah,
absolutely.
So I don't know that much about that part of the world or that time frame, but
but it's interesting, right? I'm going to check out that book. It's what the England during the American Revolutionary War. Is that what you said?
What was it?
Don't worry about it. I'll find it.
I can look up the title because it's on my iPhone, of course.
But let's talk about the music before we end the show, right? You said you like rock music. Have you been listening to any rock music of late? Do you like modern rock? People say rock is dead, but we keep it alive. So
so I grew up. I was in high school in the 70s. I saw Led Zeppelin from the 25th row in Philadelphia. Wow. I can still remember watching Jimmy Page play. I saw The Who. I saw Jerry Garcia play a couple of times. I never saw Jimi Hendrix. I was too late, too old for that. Aerosmith.
Did you see Boston? Boston?
No, I never saw Boston. I was in college when Boston came out. I wasn't a Boston fan, to be honest. I like crazy guitar players like Jimmy Page and Jimi Hendrix, and Jerry Garcia, and yeah.
Pete Townshend.
He was a rhythm guy.
Yeah, rhythm guy, absolutely. He was not a lead guy.
Kurt Cobain, I really like his guitar playing. It's crazy. And my daughters, they're teenagers. They listen to some modern music, and sometimes I think it's all crap. And then every once in a while, like my daughter Catherine was listening to this guy, and he does this weird rap over these old jazz songs, and it's so interesting and complicated. I just couldn't believe it. And it's like,
are you paying it a compliment, or are you pushing in a snide?
Oh, it's really great.
Really?
Yeah.
Okay.
Oh, the weird thing is modern musicians, like guitarists, are so good. Like there's so many people who can play better and faster than Van Halen or Page. Like the technique for guitar playing is fantastic. And they're really good. But they all say that the music you grew up with as a kid will always be the music that you love.
Yeah, that's also
I still
very
listen
funny.
to Led Zeppelin in my car at high volume, and I'm a nut for that stuff.
So are you a Led Zeppelin 4 fan, or are you a physical graffiti fan?
Led Zeppelin 4. I like his bluesy, crazy stuff.
That's it's been an amazing conversation, Jim. Thank you so much for being on the UpStream Life, and I'm certainly going to meet you in Bengaluru soon. Thank you so much.
Yeah, I look forward to seeing you. Thanks for the chat.
I'll see you in a bit. Thank you.